Alright, this video is Introduction to Definite Integrals. We want to find the area of the shaded region, and I'm going to move this over and show you this shaded region. It's the region that's in blue right here for this function, which is negative x squared minus 3x, which would be the top function. And then we have the bottom function, which is the x-axis, right? Which is the line y equals 0. Okay, so what I want to do is I want to find the integral, because an integral gives you area. Now, the integral goes from negative 3 to 0, because that's where the curve f of x intersects the x-axis, and it's negative x squared minus 3x dx. Okay, and that integral will give you the area between that function and the curve. That's what integrals do. So I'm now up top going to write a little formula, which is called the fundamental theorem of calculus, which says the integral from a to b of f of x dx is equal to the antiderivative evaluated at b minus the antiderivative evaluated at a. Alright, so I'm going to take the antiderivative, which will be negative x cubed over 3 minus 3x squared over 2, and that's going to be evaluated from negative 3 to 0. Those are called my limits of integration. Alright, now what I'm going to do is I'm going to plug in 0, so I get 0 cubed over 3, and that's 0, minus 3 halves 0 squared, which is 0, minus, now I'm going to plug in negative 3. So your negative 3 cubed is negative 27, but negative. So I get positive 27 over 3, which we know is really 9, minus 3 halves of 3 squared, so 3 halves of 9. So what I have is negative 9 minus 27 halves. Well, 9 is really 18 halves minus 27 halves. So what I get then is negative 9 halves, which ends up being just 9 halves. So the area, this blue shaded area here, that area is 9 halves, or 4.5. And that's a pretty useful thing in a lot of fields like economics or finance or physics. So let's look at a second example. Okay. Number 2 is a little more wordy. It says find the area of the region bounded by the graph of y equals 2x squared minus 3x plus 2, the x-axis, and the vertical lines x equals 0 and x equals 2. So x equals 0 is right here, x equals 2 is right here. So I'm going to draw in some lines and the x-axis, right? So I'm going to just draw some hash marks to show what I'm finding the area of. You can see that if I slide the paper over a little bit there. And now I'm going to set up my integral, which is going to be 0 to 2 of 2x squared minus 3x plus 2 dx. Okay? So that means I'm going to take the antiderivative, and I get 2x cubed over 3 minus 3x squared over 2 plus 2x evaluated from 0 to 2. Really, usually there's square brackets there. And now I'm going to plug in 2. So I have 2/3 of 8 minus 3 halves of 4 plus 4 minus, I plug in 0, I get 0 minus 0 plus 0, which is really just all 0. So now I get 16 thirds minus 6 plus 4. So it's 16 thirds minus 2. So working that out, I get 16 thirds minus 6 thirds. So I get an answer of 10 thirds, or about 3.333. Okay, so that's what an integral is.